Continuing on in the middle of section 7.2, we're going to take the idea of standardizing and finding a z-score so we can use our chart like we did above to find probability. So as we read through the problem, guys, let's label what we can, all right? So it says, on average, people use their computers for 2.4 years. What's the symbol for average? Mu. So we'll just label that mu. With a standard deviation of half a year. What's the symbol for a standard deviation? Sigma. If a person's randomly selected, find the probability that she used her computer for less than 2 years. So the everyday person, the person that we're trying to figure out, that's always going to be X. That's going to be that specific scenario, that specific data value. And this is very important, but if you don't catch it, it's not that big of a deal. Assume X is normally distributed. A normal distribution means it has that normal bell-shaped curve. So if it has a normal bell-shaped curve, we can change it to the standard normal curve. If it didn't say that one sentence, we technically couldn't do any of this, okay? So what I'm going to do is I'm probably going to make you do way more steps than you need to, but I'm trying to pound in the idea of what exactly we're doing, okay? So let's draw just the normal curve. The normal curve, guys, is your bell-shaped curve for your specific scenario. In this case, it's how long you've owned your computer, okay? When you draw your normal curve, what's always in the middle? The mean. In this case, what's our mean? 2.4. Then we're going to go ahead and label the part that we care about. We care about asking someone, hey, how long have you used their computer? And we care about them saying 2 years or less. So where would 2 be on this graph? Would it be on the left of 2.4 or on the right of 2.4? Right, it's just a number line, right? 2 somewhere over here. We don't have to be specific. I just want it on the correct side of the mean. And then less than means we're shading what direction? To the left. Okay? So supposedly how long you own your computer shows a normality or a normal curve. Meaning on average people own their computer 2.4 years, some own it less, some own it longer, so we follow this normal curve. But does this chart talk about how long you own your computer? No. So what we're going to do is we're going to take this normal situation, how long we own our computer, and standardize it, meaning changing it to a z. And that's using that z-score formula from chapter 3, okay? So let's write it down. It's z equals x minus mu over sigma. And if you remember, I mentioned it on Wednesday, it was that way to compare apples to oranges, right? Like, I now can standardize it and use this one gray chart. All right, so the key thing is to make sure your x and your mu get in the right spot. Typically putting the standard deviation in the bottom is not an issue, but a lot of times we have our x and our mu flip-flopped. Remember, your mean is always what's told to you. It's the average, so that's in the back. That's the 2.4. Your standard deviation is always told to you, 0.5. And then the part of the question, owning the computer for less than 2 years, that's that specific value that goes in front too. Okay? Order of operations, just make sure you do the subtraction first. Some of you I know will just put it in your calculator exactly like that and you'll get something that's way off. Make sure you do the subtraction first before you divide. So you should get negative 0.4 over 0.5. Does that look right? And then do your division. Round your z-score, even though we don't really need to, round your z-score to 2 decimals because that's what our chart tells us and we want to be comfortable with that. So this is a z-score of negative 0.80. But realize the z-score, guys, that's your middleman. He's still not telling us the probability, but he's our middleman, meaning now we can go to our chart and find the area that corresponds to negative 0.8 and go from there, okay? So go ahead, if you got this written down, flip it over to the top of page 7. On the top of page 7, it says draw the standard normal curve. You're like, well, didn't I just draw a curve? You did. You do the normal curve, but now we want to draw the standard normal curve. Why is the standard normal curve different? Because his mean is always what? Do you remember what his mean is always centered at? 0, okay? We're standardizing it. And then any value negative will be on the left, any value positive will be on the right. What was our z-score? Negative 0.8. So don't you agree it's to the left somewhere, kind of like our 2 was? So the whole idea, guys, is once we standardize it and once we graph it, we're shading the same amount of area. The probability of owning your computer less than 2 years is the same thing as a z-score being less than negative 0.80. And we can calculate this one. We have a chart for the standard normal curve. So that's when we'll use this chart, okay? Remember, celebrate the small things in life. If it wants it to the left, that's the easy thing. You just go look it up and you find the area, okay? So remember, how do we use this chart? These will have the 1s and 10 spots, so we're going to go down to negative 0.8, and then these columns are the hundreds, so it's just negative 0.80, so it's just 0.2199. Okay, the area is 0.2119. Okay, I'm going to write it in a couple different ways, all right? As far as, I'll tell you what I expect on the test, but what I'm writing here in a second, I don't expect for you to do, but I'm trying to show you the transition, okay? So the question asks, what was the probability that she owned her computer less than 2 years? So our value was x was less than 2. That was our initial question. What was the probability that our normal variable x was less than 2? And we said, well, crap. We don't have a chart that talks about how long you own a computer. So what did we do to x? We changed it to a z. And what did our value of 2 change to? It changed to a z-score of what? Negative 0.80. Once we changed it to a z-score, we could find that probability. It was 0.2119 or 21.19%. This is all I'm looking for on the test. I'm just looking for the answer right here. The reason why I want to point this stuff out is for 2 things. One, to understand what the heck are we doing, okay? Your z-score is your middleman. You're going to take everyday situations, which they call x, and take those numbers and change them to a z-score, okay? And then once you find the z-score, you will find the corresponding area, and that area represents the probability, all right? That's number 1. I just want you to see what exactly our transition is. Normal everyday stuff to a z-score to the chart, all right? Number 2, the other thing I want to point out is some of your MyMathLab problems, all they do is they say something like that. Find the probability that x is less than 2. That means somewhere in the problem, they've labeled a mu and they've labeled a sigma. And you need to know that this is your x value to plug into that equation, x minus mu over sigma, to get a z, okay? So some of the MyMathLab problems don't even have a word problem with them. They'll just say, find the probability that x is less than 2. All right? What does this mean in everyday situation? If I just went, for example, Caitlin has her computer. How long have you owned your computer?
A year.
So what was the probability that she owned her computer less than 2 years, which she said? We had a 21% chance of her saying a number less than 2. And we should go to Vegas because she did own it less than 2 years, okay? That's all it means. You could flip it and you could say 79% of people have owned their computer longer than 2 years, right? We have this whole idea going on there, all right? So I'll write it in words. The probability of owning a computer less than 2 years is 0.2119, okay? Another way you can think of it is percentiles. Remember, percentiles, you're shading to the left. So you could say you're in the 21st percentile if you own your computer less than 2 years. You are in 21st percentile if you own computer less than 2 years. All right, so there's lots of different interpretations, and I want to do my best to try to explain it to you because I think that's sometimes the hardest part of the MyMathLab. You can do the computations, but when you get to that part where it's like you're interpreting, you're like, I don't know, I just did the math. You know, I was that student where I could just mimic the math, but I didn't necessarily know what I was doing. So we are answering that question. If we're randomly asking someone, how long have you owned your computer, we have a 21% chance that they give us a value less than 2 years, and that's what happened. Caitlin owned hers a year, okay? So we had a 21% chance of that happening. All right, so what we're going to do is we're just going to get example after example like that. I only give you 2 because I don't want to beat a dead horse, but I can't show you enough really. All right, so let's look at the next problem. It says shoppers spend 45 minutes on average. So what can I label 45 with? Mu. With a standard deviation of 12 minutes in a mall. So what can I label 12 with? Sigma. If the distribution is approximately normal, find the probability that a shopper spends between 24 and 54 minutes in the mall. So these are 2 x's. This will be x sub 1. This will be x sub 2. Do you really need to label it with a sub 1 and sub 2? No, you can label them both x's. So again, not that you would be doing this, but say you're at a mall and you see someone shopping and you randomly go up to them and say, hey, how long have you been shopping in the mall? We want to find the probability that their answer is between 24 and 54 minutes, all right? So what we're going to do is we're going to draw the normal curve first. Remember, the normal curve is your everyday real-life situation and values, okay? Your normal curve is always centered at the mean, which in this case is 45. And we want to label 24 and 54. Where would 24 be on here? On the left, and pretty far on the left, right? And where would 54 be? On the right. A little bit closer to 45 than 20, you know. And then what do we care about shading? We care about in between those 2 values. So what are we going to do? Shade between those 2 values, okay? So if we did it to scale, which I'm not saying we're going to draw it perfectly to scale, but we've shaded a majority of our graph. So when we go find our area, we shouldn't find an area of like 0.2, right? We should have a decent sized area here. All right, does this chart tell us how long people have been at the mall? No. So what we're going to do is we're going to change our everyday x values to z values so we can use our chart, okay? So we're going to do it for the first one. So let's do z equals x1 minus mu over sigma. And we'll do z equals x2 minus mu over sigma. So we'll just do it twice. Notice it's the exact same formula. It's just that our x values are going to change. For one scenario, it's going to be 24. For the other scenario, it's going to be 54, but our mean stays the mean of 45, and our standard deviation stays a standard deviation of 12, okay? So this is going to be 24 minus our mean of 45 over a standard deviation of 12, and this is going to be 54 minus our mean of 45 over our standard deviation of 12. All right, and again, make sure you do the subtraction first. So we're going to get a difference of negative 21 on top divided by 12. So that's negative 1.75. And then on top here, 54 minus 45 is 9 divided by 12. And so that's just a standard deviation or a z-score of 75. So kind of keep in mind, again, z-scores might never ever make sense to you, but z-scores just mean how far away are you from the mean in terms of standard deviations. So we were almost 2 standard deviations away from the mean when we were 24 minutes. That's why it was close to 2, right? And we're not quite 1 full standard deviation away. We weren't 12 minutes away from the mean. All right, notice when we go to draw our standard normal curve, and again, you guys do not have to draw a single darn curve if you don't want to, but I want to show you that everything should line up nicely, okay? A standard normal curve has a mean of what? 0. And our x value of 24 changed to a z value of negative 1.75. Shouldn't he be over here kind of where we had the 24? Sure will be, okay? And then our x value of 54 changed to a z-score of 0.75. So shouldn't he be over here close to where we had the 54? Okay? So the whole idea is when you shade this, you should be shading basically the exact same region. Because 24 minutes was less than the mean, which gave us a negative z-score, which means we should be to the left of 0. 54 minutes was more than mean, gave us a positive z-score, so we should be to the right of 0. All right? At this point, since we have a z-score and we have a standard normal curve, we can use our chart. Do you guys remember what you needed to do when you had 2 z-scores, what you had to do with your areas? Subtract them. So we're going to find the larger one first. So let's figure out what the z-score of 0.75 is and the z-score of negative 1.75 is. So, again on our chart, guys, we're just going to go down to 0.7 and scroll over to the 5th column. When you do that, do you guys get 7734? And then when you go to negative 1.75, that means you go down to negative 1.7. Oopsie, I'm pointing to something. And then you scroll over to the fifth column. So then you get oopsie, I want to do it vertically. Does that look right? So the difference ends up being 73.33. And again, make it make sense to you, like, not that we're perfect drawers and shaders and stuff, but we should have shaded a good chunk of our graph, so this should be probably more than 50%, all right? So what the heck did we find? We found that if we go around the mall and ask people randomly, how long have you been here? We have a 73% chance that they give us some answer between 24 and 54 minutes, okay? So how do we write that in that weird inequality? You don't have to do this. Any other teacher might make you do this, but I won't. We start with our normal everyday value of x being between 24 and 54. And we said we don't have a chart for that. We don't have a chart that has 24 minutes and 54 minutes spending at the mall. So what did we have to do? We had to change each of these values to z-scores. So they changed to negative 1.75 and positive 0.75. Okay? So notice your variable went from a normal x to standard normal z. 24 went to that negative z-score of negative 1.75. And 54 went to that positive z-score of 0.75. And what was our answer? 0.7333 or 73.33%. And guys, this is all I am looking for an answer, okay? You do the math and just circle it, and that's what it is. In words, what did you find? That the probability that anyone's been in the mall between 24 and 54 minutes is 73%. Okay? I don't give you to the right of, but it's the same idea, guys. What you would do is you would draw your normal curve, you would shade to the right, you would standardize it by changing it to a z-score using this formula. You would shade to the right with your z-score, and then you go look up that z-score and subtract it from 1, because it was the complement rule. But again, they're going to give you every situation. Like any situation that's a normal variable, they'll give it to you. And the key thing is the z is the middleman, okay? Take that normal variable, change it to a z-score so you can use that chart. Are there any questions on those two examples? You guys okay? All right, so this direction's probably the more common one as far as doing it in math classes. But to me, it's not the most common in real life. What do I mean? How many of you guys are going shopping and saying, what's the probability that these people have been here that long? No, you're not going to sit here and start calculating that stuff, right? The other direction makes more sense. So sometimes we're given a certain percentile. For example, criminal justice, nursing, whatever it may be. Sometimes to get into your appropriate field, you have to score in the top 10%, right? So a lot of times they give you a percentile and you need to know that cutoff score. Like if I'm going to do the physical fitness test to be a police officer, I have to score in the top 10% for sit-ups. How many sit-ups do I need to do? Okay? So going backwards makes a lot more sense. So what we need to do is first we're going to practice with generic with no story problem, and then let's see what happens. And I think this is a trickier way, but you guys end up getting it, okay? So often we don't want to find the proportional probability or percentile. We actually want to find the value of a normal random variable that corresponds to that proportion, percentile, or probability, okay? So how do we take area and change it to z-score? Well, that's what we have to realize. The first instance they give you a percentage, they've given you an area, okay? So say they said find the z-score for which the area to the left is 32, okay? Well, what do you guys notice about this? On Wednesday, I had you label this, right? On Wednesday, I had you label this, and you said all of these values are area to the left, and all of them are written in 4 decimals, okay? So anytime you're given an area, make it 4 decimals. So I'm going to add 2 zeros on here. My pencil wants to go away. I'm going to add 2 zeros. So this, guys, is the area. So say, for example, I don't know why you'd want to be this low, but you just want to be in the 32nd percentile, okay? So the area to the left is 32% of the chart. What we're going to do, and this gets kind of difficult, is we're going to look in here. We're going to do a reverse lookup, and we're going to look in here and see how close to 3,200 we can get. Okay, so how do I do this? Let me zoom in a little bit. I run down the first column real quick until I get to like the 0.3s or 0.2s. So I'm skimming down here real quick, and I notice that here I'm like in the close to like the 3200s, and I just kind of move this direction. So if I go to 3085, it goes down, so I know that's the wrong row. So I go down to 3446, and I just keep skirting across that road, noticing that they're going down, 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 until I get to 3228, and then 3192. Do you guys see those two values? So, will 3200 be here exactly? No. Probably 99% of the time, guys, you're not going to find the exact area. So what we have to do is we have to estimate, and we have to just get as close as we can. It's not price of right rules. You don't have to be below it. You have to be as close to it as possible. So who's closer, 3228 or 3192? 3192, right? He's 8 off. He's 28 over. Do you guys see what I'm talking about? So the 3192 is the winner, but that's just the area. We want the z-score that goes with it. So skirt out to the left, negative 0.47, okay? So let's see if we can kind of fill in our notes. It says, look in the middle of the table to find 3200. The nearest we got to 3200 was 3192, and that was a z-score of z equals negative 0.47. And again, right now, that doesn't make any sense to us. A z-score of negative 0.47 means jack. It's not until we turn it into a word problem and go backwards that says, oh, if I need to be in the 32nd percentile for sit-ups, I only need to do 8. Okay? We haven't done that yet. The z is just our middleman. All right. So the key thing is if they give you a percent, they have given you an area, which means you got to go backwards. Okay, look in the area and go out. So find the area to the right of. They're going to get tricky, okay? So it says, finding the z-score for which the area to the right is 4332. What we have to realize is that these areas are only areas to the left, right? So, since the table only gives us left of amounts, we must think if the right of it's 4332, then that means to the left of it would be what? 1 minus 4332. What's 1 take away 4332? What do you guys get? Thank you, ma'am. Okay, so this is the area we're going to look up. Okay, that's the area we're going to look up. So again, I just go down that first column really quick until I get to the 5 6s, 5 5s, and I start going across my row to see how close I can get to 56 68. Okay, so here we're like 57.93, but then it goes up to 58, so that's going the wrong way. So here's 53.98, and I'm going to skirt across until I can find 56.68. Here's 56.36, and then we jump over at 56.75. Which one's closer? Say it louder. 56.75. Again, think like the last two numbers. 75 is 7 away from 68. 36 is what, 32 away from 68? So he's the winner. So what z-score goes with him? 0.17. So the z-score is 0.17. Let's put like the area that was close to it. What was it, 56.75? So you know where that came from. Oopsie, I'm writing it where you can't see it. Anybody have another idea what's another way we can do to the right of? Do you remember the symmetry idea? Instead of looking at the value and subtracting it from 1, we could look at the negative version of it. So what you could do, guys, is you could see how close to 4332 you could get. And guess what z-score that's going to be? Negative 0.17, and just realize the positive version will give you that. Okay? So the areas to the left, when you're shading to the left, are obviously the easiest. See how close you can get to that area. If you're shading to the right, though, we're looking at the opposite. And the whole idea is, again, think about it. If the area to the right is 4332, then what does that leave for that? The complement, right? And that's where that 5668 came from. We just did the whole graph's 1 minus the 4332 will give us the same exact z-score that cuts both the top and bottom off. All right, last one. It always seems like it's the most complicated, but then you guys do really, really well with it. If we want to find the middle of, okay? So it says we'll often want to find a middle range where we find the middle 90, the middle 95, the middle 99. So we have like this lower and upper bound. Notice we'll have two z-scores. What we have to do is we have to think complement divided by 2, and I'll talk to you about it. So this is a picture of what the middle 90% would be. If the middle has 90%, right, and it's labeled up here. If the middle has 90%, how much does that leave for the outside? 10%, but how many tails do we have? 2. So what do we have to do with that 10%? We have to split it equally, right? So this is 5% here and 5% here. And you're like, well, what's the point of doing that? Because once I find this z-score, which is to the left of, and he's really easy to find, this z-score will be the exact same z-score. It'll just be the positive version of it. So say like this was -2. This z-score will be +2. So we really only have to look up the left tail, and how we're going to get it is we're going to take the complement divided by 2. So I'm going to have you help me find it out right here, okay? So let's see. We're going to do this one. Find the z-score that divides the middle 95%. We're going to jump right down there, okay? If we have the 95% on the middle, how much does that leave for the outside? What is it, 5%? Is that okay? So this means we have 5% on the outside, or how much in each tail? 2.5. Guys, and we can even draw a picture. I don't know if that helps you. Mines are never good. So we have z equals. So if we have 95% here, right, that leaves 2.5% here and 2.5% there. Does everybody understand where 5 came from? It's the complement of 95. Is that all right? And then 2.5 is just taking that divided by 2. All right? So what we're going to do is we're going to look into the table to find the values closest to 0.0250. Okay, we're looking at this tail. So how close can we get to this one tail, 0.0250? I think this is one where you actually nail it right on the head. If you look in your z-chart for 0.250, you'll find it. All I did, guys, was change my percent to a decimal, okay? I just changed my percent to a decimal so that I could use my chart. So if you scroll down, 0.025 is right here. It's -1.96, okay? So the value of the z-score is -1.96. So what does that mean for the middle 95%? Well, he'll be what? -1.96. But what will this guy be? +1.96. We know that the graph is symmetric. So if we can find the lower cutoff, the upper cutoff will hold the exact same amount in its right tail, so it'll just be the positive, okay? So whenever you need to find the middle, guys, you take your complement and divide by 2. So what was the complement of 95? 5. When we divided by 2, we got 2.5, but we changed it to a decimal, and we saw how close we could get to that, okay? That gave us a z-score of 1.96, so we knew our lower bound was -1.96, which thus means our upper bound is 1.96. All right, one last concept before we jump into the word problems that go with this is we are often interested in the z-score that has a specified area to the right. And this is what I was talking about. If you're in criminal justice, nursing, even just in general going for a certain position, they want the top 15%, the top 10%. We want that right tail. Since it's so special, it has its own notation, Z alpha, okay? And it's tricky because you see alpha, and you want to think that's the area to the left that you can go straight up and look up. Nope, it's the area to the right. So alpha is the area to the right. So we always have to remember to actually subtract it from 1 first, then go look it up, okay? So once you kind of circle and underline the right things, I have an example of it on the top of page 9. To make sure we're understanding it, okay? So say, and actually I'm going to write in words what we're finding, okay? So find the value of z.25. So this is the top 25%. So in order to be even questioned for an interview, you have to be in the top 25%, all right? So if that's the top 25%, then we want to find the area that corresponds with an area to the left of what? What's the complement of 25? You got it, okay? So we want the area of 75%, but that's actually going to be 0.7500, right?